Assalamu alaikum everyone. So let's continue in this video about variables. So we've seen in video 1 what are variables in this chapter, that is algebra chapter, right? So now we had took the example of L pattern, right? How many patterns how many matchsticks are needed for L, and how we had come to the conclusion with some expression for forming different L's, right? In a similar fashion, let's do it today for triangle. Okay, so for a triangle, how many matchsticks do I need? I will need 3 matchsticks, right? 1 2 3 for one triangle. Now if I want to take two triangles, yes, I will need 6 matchsticks, right? So if I take some observations from this pattern, what some pattern you are going to get. So number of triangles formed if I am taking here, okay. So and in the second, if I take number of matchsticks required, okay. And then observation, what observation you have, you will look at this, okay. So for one triangle to be formed, how many matchsticks we've told we need? For one triangle we need 3 matchsticks, okay. So you will do this as 3 matchsticks, right? So for one any triangle you'll take 3 into 3 matchsticks, so 3 into 1, okay. So now let me draw this properly. All right, so now if I want two triangles to be to get to form, to make two triangles, I will need how many sticks? 6 sticks, right? For this triangle 3, this triangle 3. So for two triangles I will need 6 sticks. All right, so how many we have? 3 into 2 triangles, so it is 3 into 2. What about for 3 triangles? I will need how many sticks? 3 3 3, it become 9. So 3, each triangle is 3 sticks, and 3 triangles we want to form, so 3 3s is 9, right? It was same as what we have done for your L pattern. So if you take for 4 triangles, I will need 12 sticks, isn't it? 12 matchsticks. So this means 3 into 4, it will give you 12. So and so on. If we go on, so in general I can conclude, or I will get an expression like for each triangle it is 3 matchsticks, and I will take a variable as n, which is representing number of triangles we want to form. So if I want to form 30 triangles, so how many matchsticks do I need? It is 3 into 30. I will need 90 matchsticks. Okay. So this is how we conclude. We come to some expression, or we get some rule. Okay, as 3n. This is called as expression, or we have concluded with some rule as 3n for forming a triangle in the with the help of the by using matchsticks. Okay, so likewise this variables are not only used for the matchsticks. Okay, you have examples like, if I take, I have you can use it for pens as well, any kind of thing which has certain pattern. Okay, you can use, you can conclude with some expression. So let me take one more example. So we have one pen. Okay, so one pen costs, suppose it is 5 rupees. All right, so I want 2 pens cost, it will be 5 into 2. 3 pens cost, it will be 5 into 3, isn't it? One pen is 5, so 3 pens it will be cost of 1 pen into 3, right? Then cost of 4 pens, it will be 5 into 4, and so on. So what pattern? Observe this pattern. So what we have 5 in common, right? And number of pens which you are you want, it is you are multiplying with that. So 5 into, take any variable, let me take it as t here. Again I have took it as 5. Okay, so cost price of pens, number of pens which you took, it in general I will take it as 5t or 5n, 5x, anything. So this will become this variable, since it is going on changing. This is 5 is constant, right? So this is going on changing, so you can take it as a variable. So anything you can take, x, y, z, t, n, a, anything. Okay, so n will represent number of pens, and your 5 is constant, which is a cost of 1 pen. All right, this is how you can use a variable to anything in which you can, whenever you look at that that quantity is continuously varying, or in general you can get to some expression. All right, now let's see use of these variables, where all we can use this. So we are looking at the use of variables, right, in different fields or of mathematics. So in geometry, what do you study? You have you study about the different shapes, right? Triangle, then square, rectangle, and circle, and many more, polygons and all, right? So I hope you have the basic knowledge about this geometry. So if you say if I say, what is if I take a square, okay, in which, let's see how is it these variables are used in geometry. Okay, so we have a square. So for this square, if I want to what would be my perimeter of the square? It will be, what is perimeter? Perimeter means ये जो these sides all together, it forms the perimeter. I'm starting with this point, so the length of all these sides together, you call this as peri. पेरी मतलब आउटलाइन के जो साइड्स का जो भी लेंथ होगा. ओके, सो L1, L2, L3, L4, L. So this all will become this is the length or perimeter of your square. Okay, so this is L, 1L, 2L, 3L, and this will be 4L, right? So my formula will be, in general, 4L. I don't know what is this length. Okay, so it can be anything. It can be 2 centimeter at this length side, that is side, this one side, it can be 2 centimeter, it can be 5 centimeter, it can be anything. Okay, so you can write it as 4L, or you can say the side as S, you can represent it as S. So you'll take S. In square, all the sides are equal, right? So if you're taking this one side as X, then all the sides will be X, isn't it? So depending on what variable you are taking, normally in formulas you will see either L or you'll see S. Okay, side S represents side. So we are taking perimeter, we will get perimeter as 4S. What is this S? It's a variable, right? So why is it variable? Because it can be anything. It can be the square of 1 centimeter, it can be a square of 2 centimeter, it can be 3 centimeter, it can be 4 centimeter, and so on. So this length of the side of the square, it is variable. It can hold any kind of value. Similarly, if you have area of a square will be what? L square, right? So side square will become area. All right, so this is you are representing it with S square or L square. So again, this is again a variable, right? All right, so it can be, if it is 1 centimeter, 1 square, it's the same. If it 2 centimeter, this length, one side of the square, so 2 square, it will be 4 centimeter square. That is area, right? So similarly, if you go for rectangle, what is your formula? Yes, perimeter of a rectangle, what will it be? So according to this thing, perimeter, what is perimeter? So if I have a rectangle of this, okay, the length, this is length L and this is breadth B, right? So this can be anything, that's why in general we are giving it as length and this as breadth, right? So my perimeter will become now what? You'll have L plus breadth plus again this length plus again this breadth, right? So your formula will be 2L, 2 into L plus B. We have 2L plus 2 breadth. So I'll take 2 as common. So it will be 2 of L plus B. So what are this L and B? They are again variables. They hold it, any kind of number they will hold. So that's why this is how the variables are used in geometry. Alright, so any kind of figure you have a circle, the perimeter of the circle, the area of the circle, again you are in general you are representing it terms of variables. Alright, so that depending on the measurements which is given, you can calculate the area, you can calculate the perimeter and so on, right? Okay, now next thing is where you use it in, this was in geometry, and in the second it is in arithmetic. See, in the previous classes I remember I have used many times x variable for the unknown, this thing, right? So I remember, do you remember we have seen the properties of whole numbers, right? So what were the properties? Closure property, then commutative property, associative property, then distributive property, right? All these properties we had used variables. Do you remember I've used for closure property a and b as the whole numbers which belongs to whole numbers, right? So that means a and b, they are variables which can hold any kind of whole number. Okay, so closure is what? If you are doing a plus b, then the output what you get, that should belong to this whole number again, right? So see, let me take this thing example of commutative property so that you can understand it properly. So what is commutative property? I have two numbers 2 3. Okay, so 2 plus 3 will be equal to 3 plus 2. This is true, this commutative property is true for your whole numbers, right? 3 plus 2 is 5. In here also 2 plus 3 is 5, 3 plus 2 is also 5. So this is true, right? So say if I take any other numbers and add and do, so you will get this property true. So in general, how can I write this? I can write this as a plus b is equal to b plus a. So a can be anything, it can be 2, it can be 3, it can be 5, whatever number. B also, it can be anything. So whatever a number you are taking here, since these two are same, so it will hold the same value, right? So thus we have this is called as equation. Whenever you have equal to sign, you call this as equation. Okay, this is also an equation. Wherever you get equal to sign, you call this as equation. If you have something like this 5n, this is called expression. Why I have 5t, I have 5x plus 2, this is also an expression. Until and unless I get equal to sign and this expression is equated to some value, till then it will call we will call this as equation. Okay, so expressions are without equal to sign, it can be with variables. All right, so when equal to comes, you call that as equation. All right, so you will write in general with variables, okay, and get the general expression for because with the variables it can hold any kind of number. We are generalizing the property. Okay, so this is how again it is a into b. Also we've seen it is b into a, right? So again here one example again I've took, it is 5 plus 2, it is, you can write it as 2 plus 5, and this is additive addition, commutative property under addition. I hope you remember these properties. And commutative property under multiplication, it is 5 into 2 is equal to 2 into 5. This is for multiplication. Alright, so in general we write this as a plus b equal to b plus a into b will be equal to b into a. Okay, so for associative property in general, what was it? It is a plus b plus c will be equal to a plus b, associative is just shifting of bracket, plus c. Okay, for multiplication I've took it as a plus b, or a into b into c, bracket shifting a into b of into c, right? So all these this a b c, they are what? Variables. They will hold some number. It can be anything, any number. Okay, all right. So the next thing is you have variables in expressions, and next you have variables in equations. Okay, so let's see these things, variables in expressions. How do you get an expression with some statements? All these things we will discuss in our next video. I hope you all are able to understand this. These are the basic things. You were asking why do we use this ABC? Why you were not able to understand. This is the reason why we use, क्योंकि ABC variables are variables in the mathematics language. Okay, so these variables, they hold any kind of numbers. So we are normalizing it, that is we are generalizing certain patterns, okay, in some this thing, in order to it so that it will become in general as a formula or equation or rule. Okay, all right, so let's stop till here for today. Assalamu alaikum wa rahmatullahi wa barakatuh.